Okay, now we have the concluding speaker for today. Mūsu noslēdzošais runātājs šodien, and I will continue in English as well. And the concluding speaker is from our neighboring country here nearby, but he's representing company Huawei, and he's going to be talking about safety of inventors and control panels, functions, I guess. So yes, I'll give the floor to Mantas. The floor is yours.
Oh, hello everyone. I am Mantas. I am working as solution manager in a company called Photomate. And today I will try to explain and speak about safety and control of solar inverters. So first, what I want to represent my company. So my company, as I mentioned, is called Photomate. We are Huawei partners for distributing solar inverters. Our area of distribution is Scandinavian countries, Eastern Europe, and Central Asia. So agenda is looking like this. So specifically, I will be discussing two main topics during this presentation: the safety features and control features of solar inverters. As we all know, solar inverters are critical components in converting DC power from solar into AC power, which we are using in homes or in industry. However, it is very important that we pay close attention to both safety and control features in order to ensure that the long life and efficiency of the inverter, as well of the safety of the installers and the users and the property. The first topic I will be representing is the safety features of solar inverters. These features are very important in preventing potential hazards such electrical shocks, fires, or overheating. While using proper safety features, the solar inverters can detect and prevent safety hazards. The second topic I will be discussing is the control features of the solar inverters. These features are more related to the support of the grid. So mainly my presentation is prepared according frequently asked questions which we are getting day by day. So I will try to conclude everything to inform what is the safety features. I will not try to go very deeply, and in case always you can contact us to get more deep information. So to start safety feature topic, it is important to understand that the primary hazard associated with the photovoltaic systems is the risk of the fire. And one of the main reasons to this risk is phenomenon is called arc flash. Arc flash occurs when the voltage between 2 points in the system exceeds certain limits, which can cause atmospheric air, which is typically an insulator, to become a conductor for a brief period of time. This breakdown of the insulation creates an arc, which can lead to the fire. So as you see in figure 1, it is shown arc welding machine. So the principle of the arc flash is pretty the same. So several factors can cause arc flash in photovoltaic system, including loose wire connection, bad crimping tools, or damaged insulation of the wire. In AC circuits, current is changing direction 50 times per second. And this means 50 times per second, the value of the current means 0. In DC, it is opposite. So the current is always the same level and always the same direction. So if an arc in AC appears, so it can extinguish like automatically when the current is crossing 0. But with the PV insulation, it is not extinguishing automatically. So the most frequent arcs in the PV installation are series arc. All types of arcs, it's shown in the figure 5. And series arcs is most common because it is hard to get parallel arcs because double insulation levels. So main is series arcs. So to avoid fires, the AFCI function must be used. So AFCI means arc fault circuit interrupter. It is electronical device designed to detect and interrupt potentially electrical arcs. Arc results in high frequency noises of signal. Frequency can be between 10 kilohertz and 100 kilohertz. In the case of an arc, the AFCI will automatically interrupt that circuit to prevent fire. It is worth to mention, it is not hard to detect arc, but it's very hard to detect arc accurately and to avoid false alarms. So Huawei AFCI represents significant advancement in this field of fire protection and solar inverters through the implementation of AI and deep learning technology. The AFCI in Huawei inverters can accurately detect and isolate DC arcs. Huawei declares 100% of confirmed arcs. Second function, which is worth to mention, it is more related to the residential installation. It is rapid shutdown function. Rapid shutdown function means that if the inverter is disconnected from the optimizers, so optimizer output becomes 0 volts. So in case of fire or some maintenance is needed on the roof, it is pretty important feature because instead of 100 of volts, you are getting zero volts, and it will be safer. And in case of fire, it can be much easier for firefighters. Very common question about is SPDs in the inverter. So SPD, surge protection device, plays a critical role in safeguarding the inverters and other electrical equipment from the surges or electrical lightning, and etc. SPD is providing a path for current, for the surge current to go to earth, and this behavior, it is saves the inverter from the damage. So the Sun 2000 inverters is designed to provide a high level of the protection against lightning and electrical surges in both sides. So it means from DC and DC sides. Specifically, the inverter achieves a level 2 protection rating on the DC side, which allows to effectively handle typical inductive lightning shocks that may encourage in the system. As a result, it is not necessary to install a separate surge protection device on the DC side. So on the AC side, it is also installed SPD type 2, but it is recommended if there is long lines for the supply the inverter, it is better to have additional SPD with higher grade installed in AC combiner. In low and voltage distribution network, residual current can pose a potential hazard to electrical equipment and person. As shown in figure 10, the residual current loop can be affected by the type of the network. With TN system experiences higher residual current than IT network. It is because TN systems has direct connection to the ground, and because usually inverters are transformerless, the current loop is flowing around through the AC to DC side and closing the loop through the ground. So to avoid this situation, to keep this current in normal limits, Huawei has RCMU, so it means Residual Current Monitoring Unit. So during operation, inverter continuously monitors residual current in real time. If RCD sensor detects any leakage current that flows through through the ground and around inverter, it is tripping the inverter to avoid additional problems. About new inverter, which is going to be released soon, 330 kilowatt inverter. It has very good advantage, which is called SSLD. Or what does it mean? It's smart string level disconnector. So this disconnector is electrically controlled switch designed to protect against 3 different types of faults. The first fault is reverse input current, which occurs when the switch is on and the reverse current is equal to the short circuit of the string. In this case, the inverter makes a logical judgment based on the measured parameters and switch off the old circuit to prevent damage. The second fault is current backfeed, which can occur if there is different quantity of modules in every string, and then additional current, backfeed current is flowing around. So this inverter is measuring the voltages, and if voltage is going through not allowed limits, it is also switching off the MPPT. The third fault is a short circuit, which can cause the DC bus voltage to drop rapidly. In this case, the SSLD function or the switch, this will be disconnected through the faulty strings to avoid further damage. To ensure the safety and proper functioning of the PV systems, the inverter, basically all transformerless inverters are deploying DC insulation resistance detection. This function during every startup of the inverter, means every morning before the startup, it checks the insulation level of the resistance level of the insulation. And in case something is wrong, it is not allowing inverter to start to avoid leakage, avoid short circuits, and etc. Very common question is about anti-islanding. So what is going to be if the grid is lost? So for this purpose, the Huawei Sun 2000 inverters are implementing the algorithm known as reactive current frequency positive feedback. So in very short, it means like in every time the inverter feeds some reactive current to the grid and checking if grid gets affected by this current. Normally, grid is very, very strong with the very low resistance and it doesn't have any effect by the small current. But if grid is disconnected, all this current makes some changes. And if those changes are not according to limits, the inverter is disconnected because it means it is working in island mode. And the last feature about safety is smart IV curve diagnosis, which is generally it is more related to ensure higher yields, but in some cases can be considered as safety feature. This feature serves as an effective diagnostic tool that can identify various issues related to the installation, including hotspots, shades, glass breakage, and potential induced degradation. In contrast to the traditional IV curve testing methods, which requires a physical site visiting and disconnection of the inverter to measure each string individually, the smart IV curve diagnosis feature can be performed remotely. This results in significant reduction in time and cost. One key advantage of the smart IV curve diagnosis feature is its ability to detect hotspots, which are decreasing model efficiency and in extreme cases can pose a fire. By detecting hotspots on early stage, by this feature, you can avoid to degradation of this problem. Okay, so hardest part is finished. So second part of the presentation is about to control features. As I mentioned in the beginning, the main features of the control, it is needed to support grid operators and support their requirements. So again, this presentation is prepared mostly about frequently asked questions. So most frequently asked question directed to service department is about this problem, like it shows in figure 18. Like during the day, inverter is disconnecting and connecting again, disconnecting and connecting again, but there is no problems in the morning and the evening. With this, the primary cause of this disconnection of the inverter from the grid during the day is commonly associated with overvoltage. It is common misconception to think that the inverter is responsible for raising the voltage of the grid. However, in the reality, the inverter works within the voltage range, which is set by the transformer station plus any voltage drop along the cable. So as it's shown in figure 19, when inverter is trying to generate 12 amps of the power through the cable, which has resistance of 2 ohms, so it is getting 25 volts of voltage drop. If you add 230 volts plus 24 volts of the drop of the cable, you are getting 254 volts on the terminals of the inverter. So in many European countries, 254 volts, it is maximum limit. So for this reason, inverter must got shut down. It is very important to recognize that the cable resistance and the distance between the transformer station and the PV system has very significant impact to the voltage drop along the cable. So an alternative approach against changing the cable to more thicker is to use a characteristic curve which is called QU. So it means if the voltage rise, inverter can consume reactive power to decrease voltage in the grid. This works pretty nice, but it has one disadvantage. So because inverter is limited by maximum apparent power, as it's shown in the figure 20, like 330 kilowatt inverter can work in 330 kilowatts if cosinus equals to 1. But if inverter is consuming or generating some reactive power, it means the maximum power is decreased. Other function, which is mainly asked for from various distribution system operators, it is called LVRT, low voltage ride through. So this feature is often used because if the voltage drop for a very short time, inverter must stay connected to the grid. If it will be disconnected, it will make this problem more worse. So for this reason, inverter is staying connected to support the grid. Usually this is problem when the grid experiences short circuits. So at this time, if the drop of the voltage is in the like it showed in the curve, inverter tries to support the grid with the reactive power and stays connected. A very common request also from DSO, like for the requirements of the generators, it is written like inverter or generally generator cannot decrease its power when the frequency is decreasing. So the limit is you can reduce power by 2% per 1 hertz of drop. So it is very good advantage of the solar inverters that inverters is not decreasing the output power according to the frequency at all. So it can work 100% even with the lower frequencies, as it's shown in the figure 23. In opposite situation, where the frequency of the power system rises, then inverter must do the opposite. So when the frequency rises, inverter must decrease the output power. And I know it is the requirement in Latvia, so it is also possible with solar inverters. This feature called limited frequency sensitive mode. This feature must be changeable. The statism, usually it is 5%, but all the DSO is asking to have changeable limits from 2 to 12%. Very common also request about ROC-off. ROC-off, it is rate of change of frequency. So inverter must stay connected to the grid if the rate of change of frequency is very slow. So if the inverter will disconnect, so the grid will lose a lot of active power, and the problem with the frequency decreasing, it will become bigger problem. Very common question about if the inverter will get limited, is it all the power going to be dissipated as a heat? So I wanted to answer this question. So no, it is not dissipating as a heat, because maximum power point controller is responsible to finding maximum power point. But in case inverter power must be clipped, it is just going from this maximum power point. So as it's shown in the figure, it is just increasing a little bit of voltage, then current decrease, and power is also decreasing. So it is the way how the inverter are clipping the power. And I can see that I am under the time. So the last final control feature is about startups of the inverter and the change of the power. So inverter can be controlled how it starts, because it will not be good for a grid if the inverter will start very rapidly. So there is possibility to set the parameters, how the inverter should start, how inverter should start after some fault, and how inverter must change the power during the normal operation. So all three functions are available. So okay, that's it. Thank you.
Thank you, Mantas, for your presentation. Can you hear me okay?
Yes, I can.
Yeah, thank you for the presentation. I guess, yes, as I mentioned to other previous speakers who are talking about technical issues, I have no clue what you talked about, but I'm sure for the people who are watching this, ESELO customers, this is useful information, valuable information, and as always, they can turn to ESELO for detailed questions, or either they can turn to you with specific questions. One thing that I wanted to ask you, you are from Lithuania, right?
Yes.
And one of the first speakers from the association in Latvia that has just formed at the end of the year, I think last year, the Solar Energy Association in Latvia. And he talked about some of the examples that they're looking at, and one of those is in Lithuania. He said that there is some projects where you can buy a share within a solar park, so to speak. There's a community of people, or in, I don't know, group, how it works. Do you know something about this in Lithuania?
So it is like one EPC company is building a huge park, and then all the people, residential people who cannot install the PV, can buy a share of it. Yes, you mean about this?
Yeah.
Yeah, so it's pretty popular here, and it's very good because you can got subsidy, but and in case you are living in the flat and you cannot mount your PV for yourself, so it's very good business idea, I think.
It's a good business idea, and I guess the state also played a role in this, so people actually are attracted in doing something like that, right?
Yeah, it should be. I don't know how legally it is made like this, but it must be made a lot of work to do it. But now it's good. But I think it's for a few years already.
Yeah, it's a pity, and for me as a Latvian, sometimes it's difficult to admit that we are again a little bit out of the 3 Baltic countries, and that we compete. We have jokes about Lithuanians, we have jokes about Latvians, we have jokes about Estonians, and back and forth. And yet we have to realize that also in this segment, Latvia is lagging behind Lithuania and Estonia. So I guess there's a lot of opportunities, because always from the business side, if you look at it, we are behind, it's not a bad thing, because then we can catch up and we can learn from the mistakes or the learning lessons that you have learned as first movers in your countries. We can learn the best practices and implement them, and maybe one day we'll be as good as Lithuania or as good as Estonia in this regard. All right, I guess it's 4 o'clock. Thank you, Mantas, once again. It's 4 o'clock. We should finish on time, because this is how we do it here in SLO. We do it professionally, right on time. So thank you, Mantas.